How do shockwaves actually work? If you've ever heard of softwave therapy or shockwave therapy, then you might be wondering how a sound wave can actually help heal the body. And it's a great question to ask. To understand how shockwaves work, we need to understand what they're designed to do. The goal of shockwaves are not to force the body to heal. The goal is to give the body a signal that healing is needed. And that process happens in two major steps. Step one is what we call the mechanical effect. It's when a shockwave enters the body and it creates a very rapid change in pressure. Think of it like a tiny mechanical pulse moving through your tissue. And as that pulse travels through the body, it compresses, stretches, and creates shear force within the tissue. In simple terms, the tissue gets mechanically stimulated. Now, before that sounds really scary, we have to realize that shockwaves are everywhere in nature. We see them in lightning strikes, thunder is a shockwave, a jet breaking the sound barrier creates a shockwave. In those situations, the forces are so powerful they can cause destruction. In fact, medicine actually uses high energy shockwaves for that purpose. For example, shockwaves have been used for decades to break apart kidney stones in a procedure called lithotripsy. At very high energy levels, shockwaves can, in fact, destroy tissue, but that's not what we're trying to do with SoftWave. Instead, we use much lower energy levels that create stimulation rather than disintegration. Now, these lower pressure waves gently stress the tissue all the way down to the cellular level. And that is where the healing process begins. But there's another interesting thing that happens when a shockwave moves through fluid inside your body. It's that tiny microscopic bubbles can briefly form. And this phenomenon is called cavitation. These bubbles appear for a fraction of a second and then collapse almost immediately. And when they collapse, they create additional mechanical forces in the surrounding tissue. Think of it like tiny pressure pulses adding to the overall stimulation. Now, cavitation is incredibly powerful in other situations. It's one of the reasons ship propellers wear down over time. It's also one of the mechanisms used to break apart kidney stones. In regenerative shockwave therapy, however, we're not trying to create massive amounts of cavitation in our tissue. We're simply creating enough mechanical stimulation to encourage a healing response. And honestly, scientists are still studying exactly how important cavitation is to the healing process. We know it occurs, we know it creates mechanical stress, but we're still learning how much of the regenerative effect comes from the bubbles themselves versus the shockwave directly. So that kind of covers the mechanical aspect of shockwaves. Step two in how they stimulate tissue regeneration is the biological response. Once the tissue experiences these mechanical forces, the cells begin to react. And cells are constantly sensing their environment. They can detect pressure, they can detect stretch, they can detect changes in mechanical load. And when shockwaves create that mechanical stimulus, cells respond by releasing chemical signals associated with healing and repair. Again, we're not sure why, we just know that they do. Growth factors are activated, blood flow can improve, cell signaling pathways become more active. The body essentially receives a message that says, hey, this area needs attention. And that process is called mechanotransduction. It's the same process we use to explain why muscles get bigger when we lift weights. Now, mechanotransduction is simply the conversion of a mechanical force into a biological response. It's one of the most important concepts in rehab. In fact, exercise itself works through mechanotransduction. When you lift weights, your muscles and tendons experience mechanical stress. Your body responds by adapting and getting stronger, and shockwave therapy works through a similar principle. The difference is that the mechanical signal comes from an acoustic shockwave instead of a dumbbell. Now, why does this matter? Because one of the biggest misconceptions about softwave therapy is that it's simply treating symptoms. But what we're actually trying to do is influence tissue health. We're creating a mechanical signal that encourages the body's natural healing process to become more active. So the goal isn't to mask pain, but to improve the environment where healing occurs. And that's why at SoftWave Bimolotherapy, we don't stop with treatment itself. We use SoftWave to create the regenerative signal, then we identify why the tissue became overloaded and damaged in the first place. And finally, we build a plan to help the body move, function, and perform better long term. Because healing tissue is very important, but keeping it healthy is what creates lasting results. So if you're curious whether a SoftWave could help your specific condition, schedule an evaluation and we'll determine whether you're a good candidate. And again, we are SoftWave Bimolotherapy in Columbia, Missouri. My name's Derek. We would love to help. Thanks for watching, and I'll see you in the next video.